So for the last example, it's also into two parts. We have milling, then we have drilling. We'll start by identifying which part involves milling, and that will be this part of the diagram. You have to visualize the diagram as if it's a full block. And then so the mill would come this way, and then to remove all this material. Then for the drilling part, to be the holes, the 4 holes at the corners, then the big center hole in the middle. So we identify the points for the milling, then we identify the points for the drilling. Now for the milling, the mill tool, when you look at the diagram, it's as if the mill tool would be like this, right? And to go upwards, then to come here, then come back to the origin. So the mill tool will be about this size, and its center would be concentric with the center of the small circles. So in identifying the points, we would use the center of the small circles. We would look for the center of the small circles. Then we'll use it as this point for the mill because their centers are concentric. Then the next point we'll need to identify for the mill is that you realize that when it gets to this point, the mill would have to do a circular movement. So we need the points for here. This point here, this will be our starting point, then this will be our ending point. Then we'll do the circular cut to meet the 2 points. So we'll need the coordinates for here, and then the x and y for the end point. Now for the drill, we will already have our point for the 4 circles. So it's left to the big circle, and that's the easiest because it's in the center of the block. So half of this and half of that. In the example, we didn't do the fillet, so I will not be dealing with that in this video. So now the center for the first point. You can see from the drawing the dimensions that from this point to this point is 0.5. So in our x, I'll make this smaller. In our x, the center of this circle would be 0.5. Then in our y, you can also see that it's also 0.5. So our y will also be 0.5. First point is 0.5 in the x. And then 0.5 and the y. The next point, which is this one, has the same has the same y, which is 0.5. Now because linear pattern is used to create the circles, if here is 0.5, this side will also be 0.5, this side will also be 0.5, this side will also be 0.5, and this side will also be 0.5. The same for the last circle. So if here is 0.5, that means 7 minus the 0.5, which will give us an x of 6.5. And our y is the same, so 0.5. like that. So found our points for here. Move on to this circle. It has the same x as this circle, and then to find the y, as I said, here 0.5, here 2 will be 0.5, so it will be the length minus 0.5, so 6 here to the 6 here minus 0.5, which will be 5.5. So sin x 0.5. But this time our y is 5.5. And for the last point, the x is 6.5. Then the y is 5.5. So these are our 4 points for the circle, and they apply both to the drill of the small circles when we are drilling in the small circles, the one we are using the mill. Now we need to find the radius of the fillet, the starting point and the end point. So our starting point here and our end point here. Now we know that from here to here is 3.5 because our width is 7. So our center line here would give us an x of 3.5 like that. And then we know that from this side to this side is 5 inches. So that means half of it, that means here to here would be 2.5, right? So if we are moving from here all the way to here, to be 3.5 plus 2.5, which is 6, and that means what will be left here is 1. We take away 6 from here to be left with 1 inch. So we know that our x coordinate for this point here is 1. Now the next thing we need to do is find our y coordinate for that same point. Now we know that here to here is 4. Now our total length is 6. So you know that it's left with a difference of 2 and it's shared equally between the top and the bottom. So here is 1, here is 1. So here being 1, if you are moving, so 0 to this point is 1. Then if you move to the top here, is 4, right? So we'll move to the top here, which is 4. So 1 plus 4 would give us 5. So on our y coordinates, the top, we are looking for this point. That will be for the end point, but for this point, as I said, sometimes you need to look at which other features are aligned with it. And what I used was, I used a circle. I used the top of the circle to that point. Now the circle's radius is 2, so that means diameter is 2. So that means the radius is 1. So if I'm moving from this point to this point is 1. Now move here, which is the half of the 4, which will be 2. So for the mill, when you visualize the mill being on the diagram, it will be around this point, and then it would it will do the circular cut so it can create the fillets like that to move up, to move like this, then create the circular fillet. So we will need a point. We need a point here and then here. These are the points we'll be looking for, because if you visualize it, the mill will be around here, then to move here like that. The circle is too big, but those are the points you need for the fillet. So you can see, as you can see, so it's around here. I use this diagram is here and then here. Now this point has the same x as the circle, so now the x of this point is 0.5. Now 0.5. Now to find the y, we would look at the circle and realize that the top of the circle is aligned with the y-axis of that point. So we need to find the distance from the bottom here to the top here. Now the circle has a diameter of 2, so that means it has a radius of 1. So from here all the way to here is 1. Now we know that this whole length is 4. So if you take half of it, here will be 2 and here will be 2. So you know that this length here is 2, then this length here is 1. You know that this length is also 1. So you have 1 plus 2 plus 1, which gives us a y of 4. So the y for this, the coordinates for this point is 0.5 and 4. Now we need to find the coordinates for this point, the x-axis, and then the y-axis. Now we realize that the y is the same as the y's for the circles on top. This is our point where we are going. The y's are the same as the one for the circles on top. So knowing that, you know that our y is 5.5. Alright, that's our 5.5. We have this. So now the x. Now with the x, was a little bit of guesswork, but because the radius of this is 1, try to draw the circle of the full arc. Let's say if the radius is 1, that means maybe from here to here would also be 1. So I added a 1 to the x-axis. So I said from here to here is 1. And from here to here is also 1. So he gave me an x of 2. From 0.5 to 2. Therefore to 5.5. Then the radius was a radius of 1.5. When I tried the 1, it didn't work, so we'll be using a radius of 1.5 for the example. So we start coding by stating our stock block. The width is 7 inches, the length is 6 inches, and the height is 3 inches. 0, 0, 3. And for the N1, we do our general settings. G19 for absolute referencing, and G20 because our unit is in inches, and then G95. Now the drilling, we have we will do 1 million, we will do 2 drillings. Now the drilling will be in 2 bits, one for the bigger circle, one for the smaller circle. Bigger circles diameter would require a different tool because the diameter is different from the smaller circle. So we use 2 different tools for the drilling, for the small holes and then for the big holes. We are going to start with the milling first. We are going to remove all this material first before we start drilling. So we shall call our mill tool. The milling has the diameter, the corner radius, taper angle, and the height. Now, with this question, you are supposed to deduce the radius of the mill yourself. Now, as you know, we know this distance is 1. So that's the width of our cut. So we shall set the diameter of the mill to 1. So it will be 2 mill. Diameter 1, corner radius 0, and the height is given in the question here. The height is 5, and you also put the taper angle. So we just set it to 0. The next thing is to reset the color for the diagram. So we shall set it to red. Then we start coding. First line of code is to tell the spindle to start spinning. So M03. And our spindle speed has been given. Our spindle speed has been given in the question to be 8,000 revolutions per minute. So we shall set the spindle speed to S 3000. Our next line of code is to tell the spindle to raise 5 inch, or let's set it to like 1 inch above the block, which will be G00Z5, and that's where we put the feed rate of 60 inches per minute, which is Z5 F60. So now when I run it, still have our stop block. So now we have our stop block. Now the next thing we do is we go to our point here. We put them in around this position here. So it will be X 0.5, then Y 0.5, then run it. Then we see that our mill appears here. Now you need to notice that in the question, we want to completely remove this whole thing. We want to completely remove it. But our mill is circular, so it's going to leave this material here. So what we will do is that we would have to go forward, and as we go forward, we wouldn't end here because it will be a circle around here, and to also leave this part here. We will tell the mill to cut to pass our point. Then we'll tell it to come back and cut to pass this point, so that it gives us the complete cut. So at X 0.5, Y 0.5, the next line of code will be, see the tools above the block. The next line of code will be G01 Z minus 20 minus 2. Remember, our height is 2. So we'll come down minus 2. Then our mill would cut to like that. Then we will tell it, instead of us telling it to go to X 0.5, Y 5.5, we will tell it to go to X 0.5 and Y 6, so it cuts straight to, or so because the X are the same, we'll just type Y 6. Now to perform a clean cut through, so if we tell the mill to come back to, if I remove the tool from, you see that that's a clean cut through the block, which is the cut you want here. And then you also realize that the cut it makes here isn't a clean cut. It makes a circular cut and leaves some material. So you have to tell the mill to come back and cut that part. So to continue. So at Y6 we tell the mill to go back to X0, Y0. This time it will also cut straight through this side and to give us a clean cut X 0.5, Y0, so and to give us a clean cut straight through like that. So now our next line of code will tell the mill to go to X 0.5, Y 0.5, so that we can move from that point to our next point. So now we are back here. Now we can move to the right. If you don't do it that way, the mill, if I move it on the other code, if I remove this and I run it, the mill will be here and to cut straight through. And it's not give you the cut of one, a cut with a diameter of 1, to give you a cut with a diameter of 0.5, because half of the mill is on the block. So when you do the cuts through, you must bring the mill back to the position, the 0.5, 0.5. So I was able to do the cut for you. So X 0.5, Y 0.5. Then we move on to our next point, which is X. Now we want to cut through. The coordinates for this point is 6.5 and 0.5. So because we wanted to cut through, we set the X to 7. So I have to cut through, so X7, the Y is the same, so we don't type it again. So I run it then to cut through. Then I'll tell the mill to come back to the original position, which X 6.5, Y X 6.5, Y 0.5, like that. Then we'll move on to the top. The coordinates for the top are X 6.5, Y 5.5. So I'll tell it to cut to a Y of 7, a Y of 6 or 7. I'll say Y 6. The coordinates are 6.5, 5.5. So I'll say a Y of 6, and it moves a cut through. That's a full cut. Now I'll tell it to come back to the original position with Y 5.5. Notice that I'm not bringing the X because the X are the same. The X for this coordinate is 6.5. So I don't repeat the X, and the X is still the same for you, which is 6.5. So now we are, so let me delete this. So now that we're at Y 5.5, we move on to our last point, which is here. The coordinates are X 0.5, Y 5.5. Since the Y's are the same, let's type X 0.5. Because we want a cut through, we would reduce the X. When you move it this way, you're reducing the X. So we will set the X to 0. And this way to go. So to give us a cut through, a straight cut through. This is how you do the normal cuts. So you have a clean cut through everything. Now to do the fillet, we raise the tool. Let's set this, raise it 0.5 inches above, because we are moving to a position and we don't want it to cut through the block. So G00 and Z 0.5. Then we'll move to our position. for milling, which was x 0.5 and y 4. You see the mill is above the block like that. The next line will be to tell the 2 using G01 to come down to the depth of 2. So that lies in this surface here. Okay, now the 2 is on the block like that. Now using circular cut, we are going to be using G02 because our cut is clockwise. So G02 for the clockwise direction. And our endpoint is x2 and y 5.5. Then give the radius. We'll be using a radius of 1.5. It gives you the fillet cut. Now the radius in the question is set to 1. When you use the 1, it doesn't do the cut. So I don't know whether it's the points I've chosen which are not very accurate, or is a question, or there's a problem with the question. But right now I'm using 1.5 to just show you how the circular cut will be done. Now we are done with all our milling. We are going to be now removing our tool and then doing the drilling. So G00, Z0.5, and then we shall be sending our tool to the home, which is x minus 0.4 y0, because we want to remove it from the area of the block. It's like that, to put it to the side there. Let's set it to 2, so it moves it completely from the block face. It's like that. Now the next part will be the milling. We shall call our tool out the drilling. We shall be doing so 2, then drill. Now we shall be doing the drilling for the small circles. So we have to deduce the diameter of the circles ourselves. So now the circles have a diameter of 0.5 here, which is shown in the question. So we'll set the diameter of our drill to 0.5. Then the circles are going to a depth of 0.5. So we shall set the depth, the height of the drill, or when we are cutting inside, we'll be cutting to a depth of 0.5. The same thing when we'll be doing the drilling for the big circle, we shall set the diameter to 2 inches. So drill diameter is 1. We know that our point angle has been given in the question to be 120 degrees. We shall set it to 120 degrees. And our height, also given the question, is 5. Then we'll set the color to green. 0. So our line of code N20, we're continuing from here, would be M03. Then we'll set the spindle speed as stated in the question to 3000 rounds per minute. So S300. Then shall raise the tool 5 or 0.5 inches above. Then we shall set the feed rate to 2. Then the next thing we'll do is we'll tell the tool to go to where our circle is, which is x 0.5, y 0. So x 0.5, y 0.5. Now our tool appears. So the tool diameter is 0.5. We forgot to change it. Yes, now our tool appears like that. Next line of code will be G01, Z minus 0.5, because that's the depth we are cutting to. So we run it. Okay, forgot the depth here is 0.5, but the depth is from here, so it will be 2 plus 0.5, which is 2.5, because if you remember, the origin of the machine puts the origin on top of the block, so the depth will be rather the 2 plus the 0.5. We are coming all the way from the top here to the bottom here, so then we run it, should cut inside like so. So next thing we'll be to raise the 2 back to Z 0.5. Then we'll move to our next point, which is X 6.5. The same Y's, so I will not type the Y. N26. Then now we are at the point we tell the 2 to cut inside to the same depth of 2.5, like that. Then we'll repeat the same thing. We'll raise the 2, then we'll move, type 37, 27. Then we'll move on to our next point, which is Y 5.5. Now we are at this point, we also tell the 2 to cut inside. So run and it cuts inside. So when it comes to drilling multiple holes, it's just a process of repetition. Like that, raise the 2, N31, then go to X5 0.5, like that. Then here we also tell the 2 to cut inside. Okay, see, we've gotten an error because we use G00 for linear cutting instead of G01, like that. So now we've done all our 4 cuts. We then raise the 2 to a height of 0.5 above the block, and then we send the 2 home, which is X minus, let's set it to 4, and Y 0, so it moves from the face of the block. Now for the second drilling, we'll call the 2 still the same drill 2, so it follows the format of the drill. Now the diameter is the diameter of the big circle, 2. Point angle is the same and the height is the same. We'll set the color to, let's try yellow. Yellow is red and blue, so we'll set the red and the blue to max. Then this should give us yellow. Then we continue. The first thing, M03 sets the spindle speed 3000. Then G00Z 0.5 sets the feed rate to 2. Now we go to our point, which is the center of the circle or the center of the block, which is X 3.5 and Y 3. So X 3.5 and Y 3. So we run it. We have a big circle, a big draw 2 with I am at the center position. So now that you are at the position, we tell the drill using G01 to cut inside. Now we are doing a cut which is through all. So we shall, the height, remember that the height of the block is 3 inches. So we'll cut to a depth greater than 3 inches so that to cut through the block. It will be G01 Z minus 3.5. And you realize that to cut like that and go through the block, 39. To raise the 2 above the block 0.5 inches. Then we shall send it to the home. X minus 40 and y 0. Like that. The color of our cut is pink. Okay, no problem. Color of the cut is pink, but no problem. So now, after we are done with everything, on the last tool we use M06 to stop the spindle from spinning. Now in previous videos I used to put the M06 after every tool. It's wrong. The M06 should be at the last part because it's the spindle that's spinning, not the tool. So it's the spindle that's spinning. So it's like if you tell the spindle to stop spinning, it won't be able to use the next tool because the tool goes into the spindle. And the last code, M42, will be M30 to end the whole program. So this is how you should have your codes. I'll put the codes in the description so you can just copy it, so that in case you want to, so that when you're practicing and you need to refer to it, it will be easier.